Hey Math 1, I'm back with another video. We are starting a new chapter. It's all about solving equations. I think you guys have seen kind of some basic ones from previous math classes. Maybe the big difference between then and now is in your first couple lessons, I'm going to have you guys document each step like a proof, and then making sure that we understand what organization looks like and really why we're able to justify one step to the next without just kind of guessing and checking all the time. So the directions are, I put a slew of equations below here, solve each equation for the given variable, and we're going to document each step like a proof. So you need to document each step to receive credit on the homework, so make sure you're paying attention to what's going on here. So are there properties to justify each step like before when we were doing sort of the order of operations proof and the combining like terms, simplifying expressions proof? And the answer is yes. So when I see negative 4 is equal to 7 minus 5x and we're trying to solve for the unknown variable x, so my given is this original statement. You don't have to write the given. I'm just saying it's a good way to, it's a good place to start. Now, oftentimes when you see people solving equations, it's usually x equals and then you have a constant number. So in order to make that happen, I'm going to rewrite this where the right-hand side and the left-hand side switch around. And there's actually a property that justifies it. So I'll put the properties over here. The first one is a reorganization property where you say, hey, I want the x's on the left just by rewriting these two sides of the equations. This is the symmetric property. Yeah. So if a equals b, let's just say we had an equation. If a equals b, that means you could rewrite the equation with the right-hand side on the left and the left-hand side on the right, and it's still a true statement. This is called the symmetric property. All right, so if you know what symmetry is, it's sort of like saying you slice something down the middle. The stuff on the left-hand side is exactly like the stuff on the right-hand side. Looking from my perspective. So, yeah, me doing that would be backed up by the symmetric property. Okay. Now, the name of the game is getting x by itself. In the order of operations state, subtraction and multiplication, you can't really simplify the left-hand side at all. In fact, you want to get like terms to combine from both sides of the equations. So when you see this 7, it's kind of messing up the operation when we're trying to get x by itself here. So it's a positive 7. I actually have a property that says that if I subtract 7 from the left and do the same thing from the right, that I still have a true statement right here. It's totally legit. All right? So that's our second property. Let's say you've got an equation if a equals b. Then, if I were to add another quantity to both sides, or rather, in this case, subtract one, if I subtracted c from the left and subtracted c from the right, I still have an equation that yields a true statement. Then a minus c equals b minus c. This is called the subtraction property of equality. All right, so you subtract from both sides of the equation, and 7 minus 7 is going to be 0. So you can just pretty much cancel all that out. You're left with a 0 minus 5x, which leaves the negative 5x on the left-hand side. Okay? On the right-hand side, you have negative 4 minus 7. Make sure you guys still remember the rules of addition and subtraction when you've got negatives. All right? Same sign, you add them. So 7 plus 4 is 11, and make sure you take the sign of the biggest one. Well, in this case, they're both negative, so it's going to be negative 11. So if there is a subtraction property of equality, it's kind of like a nice fluid next step to say that there's also an addition property of equality. So if A equals B, then I can add C to the left, add C to the right, and still have a true statement. Then A plus C equals B plus C. All right, so this would be, I'm just going to put it over here because it seems like I'm running out of room. Addition, property of equality. So yeah, that just means I can add to or subtract from both sides of the equation. Now I'm very close to getting x by itself here. I've got negative 5 times x equals negative 11. If I could do an operation that would make 1x stand alone, then I'd have my answer. So what would I do to negative 5 to create a positive 1? Well, I can divide, which is the same thing as creating a fraction, by negative 5. So negative 5 divided by negative 5 equals 1. I've got that 1 in front of the x. But whatever I do to the one side, I have to do to the other. So negative 11 divided by negative 5 is my other part. So a negative divided by a negative, remember, is a positive. 5 goes into 11, 5, 10, twice. And then there's 1 left over. All right, so 1x is the same as x. So I really don't need the 1 in front there, and I've used the fourth property that shows up here. The fourth property states if A equals B, then I can divide both sides by the same number, and it's still a true statement. Then A divided by C equals B divided by C. So we've got the division property of equality as well. Division property of equality. Yeah. So we've solved this equation. And I should also point out, if we had a subtraction, we had an addition. If we have division, then we're also going to have multiplication. Because check this out. What if I were to say in an alternate reality that, hey, I can create a 1 by multiplying by the multiplicative inverse? All right? What's the inverse of negative 5? Well, the inverse of negative 5 over 1 is 1 over negative 5. So technically, dividing by negative 5 is the same as multiplying by negative 1/5, which will yield the same solution. I guess what I wanted to highlight here is that if I have an equation, then I can also multiply both sides of the equation by the same number and still have an equal sign. So I could multiply by C on the left and multiply by C on the right, and it's still good. So A times C equals B times C. That's the multiplication property of equality. So, quick recap. I'm going to start over on this proof and just show you what it would look like with those 5 properties. And then I'll make a new video where we go through the examples on the notes. So I'm given negative 4 is equal to 7 minus 5x. In this particular situation, I want to rewrite it with the x's on the left. So my first move is going to be to say, I want my right-hand side, 7 minus 5x, to be on the left. That would be the symmetric property, and I would label it like that. Second move is noticing that I have a positive 7 that can be combined with the negative 4 on the other side. I'm going to subtract that positive 7 from the left, subtract it from the right, and I get 7 minus 7 is 0 minus 5x is equal to negative 4 minus 7, which is negative 11. This property right here is the subtraction property of equality. You know what? I'm just going to use S, subtraction, P, property of equality. SPE, subtraction property of equality. And then the last move on this problem would be to divide by negative 5 on the left, divide by negative 5 on the right. That would give me the division property of equality. And then like I said before, a negative divided by a negative is a positive. 5 goes into 11 twice with 1 left over. So yeah, this is what it's going to look like on tonight's assignment.